Hello friends, welcome back to my YouTube channel MS Maths. In this video, we are going to discuss the pressure of fluid at rest. Whenever the fluid is in the rest position, then what is the pressure on the surface from the fluid? So we'll discuss in this lecture. In the previous lecture, we have discussed some examples and the equation of continuity and like basically the concept of the nature of this fluid, acceleration of the fluid, and we have already discussed that topic basically, like what is the nature and what is the streamline, streak line, potential function. All the topics we have already discussed, so you can visit our playlist so that you can get all the lectures of the fluid dynamics. In this case, or in this lecture, we'll discuss the pressure of the fluid on the rest position. Let us consider a fluid element in a control volume at del x, del y, del z. As the fluid is in rest, then also the element of fluid will be in rest in various forces acting on it. So basically, if I have this container and I have considered the fluid element in this way, that it is my x-axis, this is z-axis, and this is y-axis. So basically, the fluid element we can represent that A, B, C, D, basically this will be O, D, E, F, and G. So the center of this is basically the P. I can consider as capital P is basically the center. Okay, so this will be the capital P, X, Y, Z is the point, or this will be the center for this. The pressure at this point is basically small p, x, y, z is basically the pressure at point capital P. Okay, so in this case, this length is delta x, this is delta z, and this is delta y. The pressure acting at a point capital P be the small p, x, y, z. So the pressure acting on the various surface. So how can we define the pressure acting on the various surface or different surfaces? That will define the pressure. The force. So basically, what is the pressure is basically the force acting on a unit area is basically the pressure. So what is the force is basically the pressure into area. Okay, the pressure into area. So the force acting on the surfaces OA, B, C. So on the surface or on the face OA, B, C, what is the force? F at this face is basically, I say, the total pressure is P. So that is P minus dou P by dou x del x by 2, because we are considered from here on this surface. So from this, the distance is basically del by x, del x by 2. Del by x, no, del x by 2. This is the pressure, and the area is basically del y into del z. Okay, so this is the pressure and this is the area. We have find the force. Now force at face DFEG. So this is DFGE basically. So for this surface, we have already calculated for this surface, and now we are talking about this face or this surface. Then what is the force for this surface is basically P plus dou P by dou x, because along the x-axis, and it is also at from the center del x by 2, and the area is basically del x del z, because this is the del x. Okay, this length will be okay, yeah, this will be del y and this will be del z. So it is del y and del z. Okay, for this case it will also del y with del y and del z. Now in this case we will find the net force. Okay, you can find the surface, you can find the force on the all the sides, that in this surface and in this surface, that you can find also. Okay, for this surface and for this surface you can find. So basically here it is opposite direction, so it is minus, and it is the positive direction or opposite sign will be there. Our aim is to calculate the net force along the x-axis. So what is the net force? Net force is basically, we can calculate the net force. The net force along x-axis, that we can represent that sum of all the force, the x-axis will be 0, the opposite direction. It means we have P minus dou p by dou x, del x by 2 into del y del x plus opposite direction of the P plus del p by del x into del x by 2 area del y del z del y del z is equals to 0. So we can find the component or that condition on this particular case. That is basically, we can write in this way, it will be P del y del z minus dou p by dou x del x del y del z upon 2 minus P del y del z minus dou p by dou x del x by 2 del y del z is equals to 0. It means this will get cancelled. Okay, then we have this term and this term, basically minus 2 into dou p by dou x del y del z upon 2. So this will get cancelled, is equals to 0, and it is negative sign will also positive. So this will be dou p by dou x del y del z is equals to 0. This is the volume. It will not equals to 0, obviously. So then dou p by dou x equals to 0. It means the pressure variation in x direction is 0. The pressure variation in x direction is 0. It means the pressure variation in x direction is 0. Okay, how is 0? Because the pressure is constant, or the function of y, or function of z, or function of y or z, because it is partial derivative, so it may be function of y, function of z, function of y and x both, or constant. So the pressure variation in the x direction is 0. If you are going to calculate in the same way for the y axis, like for surface, same as for surface BEAD and CGOF. BEAD, similarly for the net force in the y direction will be 0, and dou p by dou x is equals to 0, dou p by dou y is equals to 0, and p is equals to constant or function of x or function of z or function of x or z. It means the pressure variation in y direction is 0. So basically, pressure variation in the y direction is 0. So now we have a phase or a direction is z direction. We have this yellow side, this yellow side. This is important. This is in z direction or in vertical direction. So in the vertical direction, there will be a force that is gravitational force. So this is very important, and this is our point of interest to calculate the net force or the forces for the surface. So the force on the face BCEG is basically in the positive direction. It will be P plus dou P by dou Z and del Z by 2. The area is basically del X del Y. Force on the face is basically downward, that is AODF. AODF is basically P minus dou P by dou Z into del Z by 2 del X del Y. So the net force along Z direction is basically the summation of Fz is equals to 0. So basically P minus dou P over dou Z into del Z over 2 into del X del Y minus of P plus del P by del Z, like plus, and it will be minus in the opposite direction, will minus, okay, into del Z upon 2 del X del Y is equals to 0. In the same manner, we have gravitational force also in the opposite direction is the K, or the force on the upper side BCEG. Here will be the minus K del X del Y del Z. Okay, so instead of writing here, we can subtract this force due to the gravitation. It is in this way, because what is weight? Weight is basically mgh. Okay, so mgh is nothing but, like I say that m is k and gh is basically the gravitational force and height. We can consider it as a volume. So the k into volume. Okay, so this will be my like in this case it will be P del X P into del X del Y minus dou P by dou Z del Z del X del Y upon 2 minus of P del X del Y minus dou P by dou Z del X del Y del Z upon 2 is equals to K del X del Y del Z. Then it will be, it will get cancelled, then it will be this term and this term will add, then minus of dou P by dou Z and del Z del X del Y is equals to K into del X del Y del Z. This term will get cancelled, then this will be dou P by dou Z is equals to minus of K, and we can simplify this as basically, or we can write it as a, like, because it is a constant, then in the ordinary derivative that dP by dZ is equals to minus K. So basically P is equals to minus KZ plus some constant. So this is the pressure on the Z direction. So due to the gravitational force in the Z direction, that is the like slight different for the all three cases. When the fluid is at rest, the pressure at initial point P is same in all the direction. Here K is small, tending to 0. It means P is obviously constant, and the same case arises that dP by dz is equals to 0. So it is the Pascal's law that at the initially the point at P in the pressure in the same direction will same. In the all direction the pressure will same. The pressure on all the point at the same depth below the fluid surface of a fluid at rest. Okay, and if any pressure is applies to the free surface of the fluid, it is transmitted equally to all the point of the fluid. These all result, this and this is called the Pascal's law for static fluid. It means at rest it is the Pascal's law for the fluid. So this is all about the pressure on pressure in the rest position of the fluid. So in the next case we will discuss the what is the Pascal law in the with the full description. So I hope you get the concept of the pressure at the fluid, pressure on the fluid at rest. So thanks for watching my video. Keep watching MS Maths, and for more video you can subscribe the channel, share with your friends and like the video. Thank you.